Hello, my name's Steve Hoffman. I work at Funnel Cloud Services. We're an AWS partner specializing in database services. And today I want to talk to you about moving an Oracle database to the cloud. Okay, throughout this presentation, I wanted to provide hands-on details, but I don't want to bore the people who are not interested in an RMAN restore command or provisioning a VPC on AWS. So when that happens, I'll call out this AWS on video below, and if you click on the eye, you should be able to see individual details of all of the code references where we show hands-on. Hands-on is going to be Bash Shell and or AWS console information. Talking about today, first we want to emphasize the network architecture and defining that and deploying that as infrastructure as code so that it's a consistent model and we can really kind of a rinse and repeat. We'll be talking about some of the nuances between infrastructure as a service and platform as a service. We'll talk about how to initially push data up to the cloud and some of the different techniques. And then we'll be talking about a little bit more of the why you want to move to the cloud. So not just pushing it up like a normal database migration, but actually moving to the cloud to take advantage of the cloud functionality and utilities that really provide a lot more of a sexy why you want to go to the cloud. And then we'll be demoing, building out, migrating an existing Oracle 12.2 environment up to the cloud over to AWS's EC2, and then also show you some of the provisioning and kind of the sexy value add that you can get once you are in the cloud. So to start in the network, we're going to deploy kind of a standard deployment for database services where you're going to have you define your range of IP addresses, the subnets that are going to be involved, and then the firewall rules, the gateways, and then just a security model of how you can communicate with on-prem. And then we'll be emphasizing that, again, it's kind of a code-defined network so that it's kind of a rinse and repeat. So this is what we're going to deploy today. It's a isolated, dedicated private network that in AWS they call a VPC. They've got a couple of subnets. Private subnet is where Oracle will live. Public subnet is where your app tiers would live. And we're going to throw a Bastion host in there so that we can communicate with on-prem. There are the security groups are the firewall rules. There's routing table entries that will take the public information on the public subnet and route it through the internet gateway. That's really what defines a public subnet, is to have these rules through the gateway. On the private side, we do still want there's a NAT gateway, which there's routing rules from the public subnet that fire through the NAT gateway, which then goes out because that's on the public subnet. And that allows you to do things like yum updates, or if you're on-prem right now and you Google what's my IP address, it'll you and your neighbors are probably have the same IP address, and that's because you're going through a NAT gateway. And we'll be leveraging an S3 bucket to take the data that we're going to push over to the from my on-prem over to the Oracle database. So with the firewall rules, it allows us to go to this Bastion host. So we'll grab what the IP address is on the on-prem solution, and then the firewall or the security groups will allow us to communicate through 22 to this Bastion host, who's on the public subnet. And then from there, there's security rules that will allow us to go from the Bastion to the database. So that could be 22 if we want to just bunny hop in and go from SSHing in over here and then bunny hop over here. So then we'd be on the database server itself. Or likewise, we could also, if we're going to be doing like a SQLnet call, we can go through 22 and then it'll go to 1521 to get to the database information, and that will be encrypted, sending back over to the on-prem solution. So it's a kind of a secure approach to it all. We use Terraform to deploy our stuff here. The nice thing about Terraform is it's available in multiple cloud providers. So you can use whatever you want, but the nice thing about Terraform is that it's consistent. So here is the Oracle deployment. So again, here is the AWS deployment. And now if we switch over and deploy this in OCI, still the same functionality of a dedicated isolated network, but now it's a VCN. It's still got a individual data centers, which in AWS would be availability zones, but now in OCI it's availability domains. They represent 2 data centers. Same approach to no longer security groups, but the security lists, and by the same approach of routing entries through the gateway. Technically, the security lists tend to be more IP based in Oracle, whereas in AWS they have security groups based on security groups. But other than that, I mean, it really is kind of a very similar layout. There's the object store bucket versus an S3 bucket. But again, here's my Oracle, and here's my AWS. And then once we've got this, define the network, this is where we kind of more of a factorization of this and pushing it out. So we take that network definition, and then there's variables that'll plug in to deploy different ones, but then we can just crank this out. And so I can create a network here, and then create another one here. So that's the whole approach to the cloud as a service. It'll allow us to deploy everything real quickly. And consist section, we're going to go to the AWS console and show what the network is as it's deployed. Once we remove that network, and then once we bring a new network back online. Okay, now we're going to touch base on some of the nuances between infrastructure as a service and platform as a service. As we'd walk down this list, the administrative tools will become more robust, but also larger vendor lock-in as we walk down. So on top of it, we just have the infrastructure as a service, and that's going to be licensed by bring your own license from an Oracle play. That would be EC2 in AWS speak. Oracle Cloud Infrastructure calls it compute service, but it's really roll your own Linux box. Full access, full root control. And then as we drill into the platform as a service, that can be licensed in either a BYOL, or you can have the licenses included from the cloud provider at an additional cost. Oracle's got database as a service is kind of a tweener between IaaS and PaaS, because it has some functionality like installing Oracle, Apacheing it, but it also still gives you full root access. So it is kind of a hybrid model. The next step, drilling down the next step in is where we get to is AWS's RDS. That's no OS access. So it's purely just access through the listener port. It's got some nice utilities for patching, cloning, backing up, restoring, and disaster recovery as well. Allow you to go to 2 different zones, availability zones real cleanly. But it is, you are living just on that listener port. So you can get database directories, but you're going to be calling data pump imports through SQL. And so once you get your heads around it, it's not that big of a deal. And then the most administrative tools provided is going to be Oracle's autonomous database or data warehouse. It's just basically create the table, and then it'll kind of leverage machine learning and for doing self-tuning and what have you. It's got some slick things where it can just dynamically change the number of CPUs that you're allocated for the box without taking a database down or anything. It's a little bit of a different use case. It's a little bit more of it's easier to see how you could build something from scratch from there. It's a little bit more difficult to see how you'd migrate an existing application to that deployment. Here's we're going to talk to about some of the migration techniques and some of the nuances between IaaS and PaaS. Again, IaaS is more of you can copy the files over because you have root access and you have OS access, so you can copy the database up to it. Whereas with a PaaS offering, you're a little bit more tied to a logical copy or a data pump import. And then the techniques, when you're moving a large database up to the cloud, like any database migration, ideal situation is you want to be able to limit your outage by copying the files up ahead of time while the on-prem is still up and running. So if that's something you can do, which is similar to an on-prem solution, but if I can do that, If this is for an IaaS model, that's more of a just done. I can do an RMAN restore and then roll forward recovery. So it allows me to do that while the system is still up and running. If we were going to do that in a PaaS play, we're going to need to do the database import and then rely on logical replication. So logical replication would be Golden Gate in OCI, or AWS has got a data migration service, which is kind of an interesting play. The DMS allows you to migrate data up, and there's no software cost, so it's just the runtime cost of while you're keeping the data in sync. For these models, it's kind of nice. If you're going to be doing it as a migration, you don't want to run the logical replication for a long period of time. You just want to run it for a while, because there are some nuances with logical replication as far as for the transactions. It's a little bit more specific than an RMAN recovery and restore is pretty kind of bulletproof. With the hybrid deployments, if you're going to be starting with maybe moving something to DR or development, but keeping the on-prem solution, with those, you want to consider creating some sort of a dedicated network, so if performance is going to be relevant there. But in the hybrid model, what's an intriguing play is just pushing your backups up to the cloud, kind of replacing your tape backups. It's got a nice model where you've got a lifecycle manager will really keep track of how long you want to keep those backups up there, and you can just create policies on that. But then once you've got the data up there, that really opens the door for doing as much cloud deployment as you want, because you've got that source of information. So with the couple of different options, really, when it gets down to pushing the data up, they really kind of boil down to, am I just going to copy the database up, or am I going to expand my network so that I've got my on-prem network integrated in with my cloud deployment? This obviously involves a little bit more work with getting your network team involved, but it is something that if you're going to be going with a hybrid deployment, you're going to need to do anyway. But if you're going to go just pushing the data up, it's nice to just push it to object storage. It's a simple model. It's a secure communication through port 443. Surprisingly, you can do it from pretty much most database servers. You'll just be able to push it up to the cloud without any network involvement. You could also use just more of an SCP model that can be you can either have that directly to a Linux box or have that be backended into object storage. With these pushes to the object storage, it kind of gets defined as a tape as far as we're thinking, and there's a very similar model from a RMAN backup. So you can either push, I can push my RMAN backups to disk and then scrape them to a taped play, or within secure backup, it'll actually integrate in. RMAN will directly integrate to object storage and allow you to just push it up, and it looks like a tape drive. And so now I'm going to show you actually pushing our database up to the cloud. Okay, on this online or hands-on section, what we're going to do is we're going to create a user account inside our AWS account. And then we're going to create an S3 bucket that we're going to be using to hold the backups. And we're going to give that user access to that particular bucket. Then we're going to go over to the on-premise, and we're going to install the AWS CLI, authenticate using that user, and then send the backups up to the S3 bucket. Okay. Once the backups have been pushed up to the cloud, it really opens up a lot of functionality where you can really take advantage of the cloud deployment in general. So, and how you really want to do that is just how we can take infrastructure as code and deploy the network. We can do the same thing with the database server and the compute that goes along with it. So we've already gone through where we can create our network. And now when we create our database, we've separated out creating the database server from the network. So it will just create into whatever network we tell it to. So it could be a brand new network, or it could go into an existing one. But with that, with the automation and with the orchestration and everything, we can wind up getting a database that's created and available in minutes. And it comes with its own network, with its own compute, and it's rolled to a specific point in time. And because we're leveraging some of the cloud-centered functionality, that database is available immediately, regardless of how big it is. So it's really kind of the holy grail of database provisioning. allows you to do things that really opens up the door for CI/CD work, or since I can create a system and deploy it, I'll know exactly how long it's going to take before it's ready, and any sort of RTO and RPO can be tested and you know what you're going with. But the disaster recovery system is not built out until you need it, so you avoid the license play there. And then it also is real interesting from a patching point of view. It allows you to roll forward in kind of a programmatic way as applying Oracle or data or OS patches. So here I wanted to touch base on how we deploy a database server within AWS. And it really boils down to there's 5 database components that we define. So one is the AMI. So we've got these machine images. So this is where you'd create a library of your own. But you start with the Linux box, you install and patch it to whatever level you need to be. Apply put your Oracle installed there, patch that to whatever you want with, and then create that as your gold image. So you could have one for Enterprise Edition 12.2, 19C. Maybe you've got some standard edition, whatever those libraries that you'll need. And then so that's your starting point. Then you add the shape, which basically gives me the CPU and RAM. So pretty dynamic of the variables you want there. And then you specify we do it at 2 different volumes, one for the database itself and one for a backup. So for each of those volumes, specify the size and the type. And again, we've separated out the network creation from that. So now we're just going to specify where is this going to live. So what's the VPC and subnet it's going to live at, and what are the security groups associated with it. Hands-on section, we're going to provision a new database server over here in our existing subnet or existing VPC. And then we're going to go over to the on-prem solution. We're going to SSH into the Bastion host. From the Bastion host, we're going to then SSH and bunny hop into the database server itself. And then from here, we're going to pull those backups that we pushed over to S3 earlier, pull them over here, and restore and recover the database. Okay, so now we've got the database server deployed, and I wanted to kind of emphasize how we're implementing it, not just as a database server, but it's a database server that comes from our factory. So this is the vanilla Linux box that we're able to take the S3 backups and or the backups stored S3, push them to the backup device, and then do the restore. But because it's part of our factory, we get it's implemented into our infrastructure in general. So our normal deployment has also got a snap script, which will, for the most part, you do an alter database begin backup, take a snap of the volumes, and then an end backup. It takes a couple seconds to run, and now I've got a copy of that database. So I take that on a daily basis, and then I can also incorporate pushing the archives to S3, which allows me to get that pure point in time. So this is the vanilla deployment. And then with this vanilla deployment allows us to have this vanilla cloning, which I take those backups, and this is how I would create a separate EC2 instance. So I could, instead of taking the 5 components that make up a database, there's an additional one added. So the original 5 are all the same as far as still an AMI image, the shape and for CPU and RAM. For the volumes, there's 2 differences, or one difference. Instead of asking for just the type and the size, it's the type and the snapshot we'll be using to provision those. And then same VPC details, and then we push it to an S3. This allows me to do that, not just the daily backups, but to roll forward to 442 on Tuesday if that's what you need. So this is the kind of the factory deployment, where we've got our definition of our database. We go ahead and deploy that database server over here. We roll forward, get it all set up to go. But now because it's part of this deployment, I'm able to implement, now I can start, that system will start snapping it and then start creating information that can be used to create a second instance. So we can go through, and while that system is up and running, and we've gone through and then we've kind of created that little test table there. So now I can provision another system and have it roll past that point of time that the table was created. And so I get a separate environment. In this case, I just created it in the same network, but I could specify a different network or create a new network and specify a different one I wanted to. And likewise, I could, if I need to, this could be used for testing, or for if this is going to become a database as a service model, we could keep this one as the source and just keep on cloning from that and create even a third. So now I'll kind of show that of once we've cloned that, what it looks like on the console. In this hands-on portion of the demo, we're going to take our existing database server that we've created and that we're rolling forward as our on the migration target. Because we deployed this through the factory, we're going to be able to ingest it back into our clone definition. And then once it's ingested back into our clone definition, we're actually going to be able to create a new database server, which is really a clone of this target system that would be available for read-write so that we can test it. And then finally, we're going to go back to our original database server, take the last of the archives, roll forward so that it's ready for the go live, and then open this database up to end the migration. And then once we've done that, we'll go back to the on-prem solution. We'll be SSHing into the Bastion host, but then that will then show you how we can tunnel in over here through 1521 and where we can then communicate from the on-premise over to the AWS database securely. Well, that's it. I'm done with the presentation. Hopefully this was insightful. Thanks for your time.